Hello guys! Hello everybody! Welcome to my YT channel. Welcome to my YT world. I'm back. Hello everybody, I'm back, but this time still a reduction and oxidation topic, but this is how to balance redox in acidic solution because we have done already in the basic solution, right? Okay, let's go directly to the example. Okay, we don't have to define reduction, oxidation because I did it in my previous live stream. Okay, I'm gonna be having the automatic examples for this. Okay, okay, I have the example. Okay, I'll show you. I have no sketch paper already to be finished. Okay, wait for a while. Okay, acidic solution. So let's say I have a chemical reaction, permanganate, okay, polyatomic ion, so permanganate, MnO4 negative plus ferrous. Ferrous meaning 2 plus. Because there are two ion exist in two phases, could either be ferrous and ferric. Ferrous 2 plus and ferric is Fe3 plus. Okay, and then we go result to manganese Mn, right? 2 plus Fe3 plus, which is the ferric. Okay, this is our specific example. Okay, permanganate plus ferrous plus manganese plus ferric. Now you are wondering where did I get these charges? So it's simply in the periodic table. For example, manganese belong to family 2A, that's why it is 2 plus, something like that. Okay, and then iron exists could either be positive 2 and positive 3, two charges. Okay, and permanganate, as usual, this is a polyatomic ion which has a total charge of negative 1. Okay, now let's balance the chemical equation, chemical reaction. So by visualization of this chemical reaction, so it's very obvious that there's no oxygen in the product side. Okay, and then in the reactant side, there is an oxygen, okay, which is a subscript of 4. So meaning to say, subscript 4 times 1 is the coefficient. So, okay, 1 times 4, there are 4 atoms of oxygen. So what will happen? We need to balance the oxygen. So now what is the rule in redox? If we balance oxygen, we need to add water on the other side that has no oxygen atoms or deficient in oxygen atoms. So we need to add 4 moles of water or 4 H2O just to compensate with the rule. Okay, we need to put that in the product side. We'll write this one as permanganate. So all you have to do is to practice a lot of chemical reactions. Then by the time you are mastering it, then it's easy for you to understand, especially if you encounter another chemical reaction doing the redox in could either be basic solution and acidic solution. The only difference is that in the final redox equation in acidic solution, you don't have to add OH. But the basic solution, you have to add OH at the end. But then only you have to add water because it's acidic. Okay, water or H plus on the other side. Okay, you remember the acidic H plus or H ion is positive, right? So we have HCl, H2SO4, like that. The presence of hydrogen ion with H plus could determine that it is an acid in organic chemistry. Okay, because it's another thing in organic chemistry. Okay, like that. So that's the only difference in between the redox in basic solution and redox in acidic solution. Now here we are discussing redox in acidic solution, meaning reduction and oxidation in acidic solution. So our final redox equation have no OH negative in the final equation. Okay, that's bear that in mind. Okay, and then over negative plus if a 2 plus is equal to and 2 plus, okay, you have to be alert with the charges, huh? Because once you will have a mistake with the charges, then entirely you have a wrong chemical reaction. Okay, 3 plus, we have 4H water. Okay, I put 4 because in every oxygen you have to add water in the side where it has a deficient in oxygen or lack of oxygen atoms. So it's here, right? Now, if we introduce the water here, then you will also add H plus on the other side to compensate with the balancing of the hydrogen atoms, because here we need first to balance the chemical equation, because this is unbalanced at the first look of the equation. This is unbalanced, this one. I'll put unbalanced, huh? Okay. Why unbalanced? Because there's no oxygen in the product side. Okay. On the reactant side, have oxygen. Okay. And here we need to balance here. Okay. Like this. So add 4 moles of water. Why I said moles? Because that is the on the side coefficient. Okay, 4 moles of water per moles beside the compound and beside the element. Let's bear that in mind. That's not atom. I will never say atoms of water. Okay, take the difference. But I will say 4 moles of water. Okay, because what is written beside the element and a compound is the number of moles, that not the number of atoms. Because the number of atoms always consider the subscript. Okay, for example, water, 2. 2 times 1 is equal to 2. That is the number of atoms of oxygen, like that. If there's no subscript, then automatic coefficient on the side to become the number of atoms. But in here, there's a subscript, so I cannot say 4 atoms of water. Okay, like that. Okay, it's very clear. Huh? So if I add water here, so the rule will add also H plus on the other side. So I have to add 4H plus to compensate to balance for the hydrogen. Okay, 4H plus here. Okay, I'm going to encircle the stuffs that I've added, huh? Like this, so that you will never be confused. Okay, 4 moles of water, then 4H plus. Again, that's the rule. Add water if you balance the oxygen in the side where it has a less number of oxygen, or deficient number of atoms of oxygen. Okay, and then since you introduce hydrogen in the water, then you have also to put H plus aside to balance the hydrogen. So hydrogen and oxygen are complementary with each other. If you add water, okay, you also add H plus on the other side. Okay, like here. So we need to balance finally the equation. Okay, 1 by 1, elemental balancing. So let's start with manganese. And in this manganese, right? Okay, manganese is 1, and the manganese also here is 1. When you balance the number of atoms, you'll focus only number of atoms. Do not be confused with the charges and the oxidation number. Okay, later. Okay, and then oxygen and iron. First, consider the elements first. Okay, the metal. Okay, 1 iron and 1 iron also. Okay, see, one iron on the right side and one iron on the left side. Because there's no number beside the iron, there's no coefficient, and there's no subscript also with the iron from left and right. Okay, and manganese also, there's no coefficient beside manganese in the reactant and in the product, and there's no also subscript in the manganese down below. So it's 1, 1. Okay, the oxygen has 4, but it is not to the manganese. It is for oxygen. Okay, like that. And then we need to have the hydrogen. Hydrogen 4 on the left side and hydrogen, okay, like that. Okay, on the other side. Okay, so 4 moles, 4 atoms of hydrogen. Okay. Hydrogen is 4 and hydrogen here is 8. So hindi pa siya balance. So, if hindi pa siya balance, you have to add 4 here. Okay? Like that. But we need to review again because it mixed me. Okay? Again, this is the power of on-the-spot live streaming. Okay. This is the unbalanced equation. And then if O4 plus, if O4 is causing positive plus A4, so we have 4 plus H2O. So we need to add H plus. Sorry. Okay? Really? So if you really know the concept, then you will wondering why, oh my gosh, this is really wrong, something like, and this is how I love, on the spot vlogging and live streaming, because it helps you think quickly that you are wrong, commits error. I don't want to be perfect because, it's very scripted, right? So that's really my purpose why I have the on-the-spot live streaming and vlogging. See, I review that is H plus because hydrogen here is 8 and 8 here. Okay, that is 8 hydrogen. Okay, like that. Now, okay, now we need to have the half reactions. Oh my gosh, what's happening? Okay, half reactions na tayo. Ito na ha. Sige na. 8H plus permanganate MnO4 negative plus Fe positive 2 Mn 2 plus Fe3 plus 4 moles of water. So how can we determine the half reaction? Okay, so now we will go to the oxidation and reduction first. That is the second step. Okay. Ato lang dagma yun ha, kasi papil. Okay. Charot. Assign oxidation number na for the step 2. First step is to balance the chemical reaction. And then second, we have to assign oxidation numbers so that we can have an oxidation and reaction determination, which element has been oxidized, and which element is being reduced. Okay. Here, I have to make another so it will not be crowded. Oh my gosh. Yes, it's very crowded, right? More crowded. Akong usbon diri para di siya maghuot, in fairness. Oh my gosh, Bisaya talaga. Okay. So H positive plus permanganate. Okay. Plus ferrous equals to manganose. Okay, because 2 plus. I don't think so there's a 3 manganese to make sure, to make safe. Okay, because 2 plus will be the OUS and the 3 plus will be the IC in rule in organic chemistry, right? Again, rule in organic chemistry, 2 plus will be the OUS and 3 plus will be the IC. That's why we have ferrous, ferric, phosphorus, phosphoric. sulfurous, sulfuric. Okay, that's matters on the charges. Okay, but I don't think so with manganese. I'm not really sure because that's a very long time ago. Okay, we talk of chemical engineering. Okay, I cannot remember really also. Okay, manganese or manganic, but I don't think so. There's a manganic. Anybody? I think so. There's nothing. Okay, I should not create my own, right? Fe3 plus water. Okay, this is gonna be the balanced chemical reaction. This one. Okay, now we do the determination of the oxidation and reduction. What element is being reduced and what element is being oxidized by assigning oxidation number individually. Ganon. So here it's very clear in the H plus that is having the charge of positive 1. Okay, no issue. For the permanganate, again, this is the issue. Okay, so the permanganate, it will be written as close and open parenthesis permanganate, okay, is equal to the overall charge, which is equal to -1. Like this. Okay, we write that here in here. So make and close and open parentheses equal to the charge -1. Just like this. The purpose of this, doing this, so that we can get each oxidation number of manganese and the oxygen. Okay, now oxygen has -2 charge. Okay, -2. Okay, and then let's do algebra also, linear equation. Let X, the number of oxidation number of manganese, equal to -1. But we need to do the algebra, the linear equation. Okay. Okay, take a look. Manganese. Okay. Okay, manganese. The superscript is nothing or 1. If nothing, that is also 1. Okay, like that. Okay, so X times 1 because there's no subscript. So if there's no subscript, that is automatically 1. So X times 1 is simply X. Okay. Okay. Oxygen, -2 times 4. -2 times 4 is equals to -8, right? -8. Ganon. Is equals to -1. Like this. This one is simply X also. No issue. Equals to 7. Like that. Okay. Oh my God! Your connection is unstable like this. So X is equals to 7. 7 is the charge of manganese that we are letting X to that. Let the X as a number of oxidation number of the manganese in which we are asking for. Okay, actually we can put that automatically +7 by using trial and error method, but I don't want trial and error method. Let's do the algebra, basic algebra like this. Okay, so X is equals to 7. So put that 7 in the upper portion of the manganese here, which is the superscript already because we have already the value. Okay. M is equals to +7. 7 or +7 is just the same. No issue. Okay, like that. And then the rest are already very easy because there's no polyatomic ion somewhere in the product. But water, you may wonder also water. Okay, let's try water. Okay, since water is not a polyatomic ion, okay, like that, and water is a polar molecule, if you can remember that, okay, polar. So meaning to say it has really a polarity or a charge, something like that, okay? But in here, so even though oxygen and hydrogen has each charges, but this is as a compound. So meaning to say, the rule will say 0. Okay? If there's no negative here on the outer portion, that means 0 for any compound. Okay? Existing as a free metal without charge. So meaning to say, this is a neutral metal. Okay? The same as water. Water also as a compound is already reacted with each other as a unique compound or a polar compound water. Okay? There's no charges. So, 0 siya. So, if that is the case, that is 0. Okay? But it's very sure that oxygen has -2. Okay? Like that. Still, you got it, but 0. Okay? 0. Okay, let's have H2O. Okay. Sige lang, magugay siya. Okay, -2 man ang oxygen. So actually, it doesn't matter. Okay, but I will just show for the purpose of explanation. Okay. It will not matter here. Actually, I'll tell you something. Hydrogen and oxygen here is not being reduced and oxidized here. Not the gases or non-metal. Hydrogen is a non-metal, oxygen is non-metal. Charge, positive charge, but let's do also the same thing with the other here. Okay, to make it fair and with justice. Charot. Ganon, it goes to 0. Okay, oxygen is -2, so +1 automatic. Okay, this one. Automatic already, so it goes to 0 because 2 times 1 is 2. With 2, okay, 2 minus 2 is 0. 0 is equal to 0. No need to show the the systematic way. Okay, like that. Okay, -2 and +1. Okay, I will tell you why hydrogen and oxygen will not oxidized or reduced. Okay, ato na siyang tanawon. Okay, so hydrogen. I said earlier that it will never oxidize nor reduce because the charge here plus is also plus here. That's why I attempt not to put charges anymore. Okay, but for the purpose of discussion, we'll just put. Okay, oxygen is -2 and oxygen also is here is -2. I forgot to put the -2. Okay, so -2 and no, there's no changes from the reactant to the product. Take note, the charge of H is also positive in the reactant, and the charge of, we'll just be waiting for the connection because sayang naman po voice. Charot. Okay, we'll wait. Okay, the hydrogen will not oxidize nor reduce, and also the oxygen will not reduce, will not oxidize because the charge is just the same. Okay, from the reactant also oxygen. Okay, now we go to the half reaction. Okay, in here, okay, since the permanganate is the reason why we put 4H2O, our half reactions, we will incorporate the water for the manganese. But again, we need to solve for the oxidation reduction, sorry. Okay, +7 to +2, manganese. Okay, di maklaro eh, sakit ko mata. Mn +7, Mn +2, so the oxidation number is reduced or decreases. So if the oxidation number is decreased or reduced, that is what? That's 1. That is reduction. Okay, like that. Oxidation number is decreasing or reduced, arrow down. Okay, so this is reduction. Manganese pala siya is reduction. So I'm going to say manganese is being reduced. Okay, in the reaction. Okay, reduced. So arrow down. So oxidation number down, like this. Okay, like this. Samok lang. Your connection is unstable. Okay, so from +7 to +2. Okay, so that is decrease in oxidation number, arrow down. See, ON, oxidation number, arrow down. That is reduced. Okay. Now, iron. Okay, from 2 to 3, there's an increase of the oxidation number. So this is undergoing oxidation. And then there is an increase of an oxidation number, meaning to say loss of electrons. So iron is being oxidized, sorry. Okay, oxidized. Okay, this iron is undergoing oxidation because there's a loss of electrons and then there's an increase in the oxidation number, then that is oxidized. Iron is being oxidized. Okay, like that. Now we need to write now the half reaction because we determined already the oxidation and reduction. Okay, it's gonna be like this. Half reaction first, we try to the reduction or any oxidation you can start, reduction also, but we can proceed to the reduction if you want to. Okay, reduction. Okay, manganese, right? Okay, reduction here is manganese. Okay, so we need to write the permanganate. Okay, and the H plus and the permanganate here and the water. Okay, why? Because this is the reason why we add 4 moles of water in the first equation that we need to balance. Okay, and we cannot break the manganese also and oxygen. It's built in with each other. So that's the technique, huh? Okay, so and oxygen and nitrogen also will go together. Okay, complementary with each other. So the reaction will be 8H plus permanganate. Okay, and then we have the Mn2 plus 4 moles of water. Ganon. So this is our reduction. Okay. Now, after determining the reduction, we need to balance the number of atoms first. And after that, we need to balance the charges. Okay, the only way to balance the charges is to put oxidation number. Okay, we should just copy from the original here. Okay, -2 like that, and then we have also -2, +1, something like that. Okay, then +2. Okay, like that. Okay, now balancing the equation. So hydrogen 8. Okay. Manganese 1 and manganese 1. Okay, very clear. And oxygen is 4, and oxygen is 4 on the other side. That 1. Hydrogen is balanced. Okay, now balance the charges. In redox, we need to balance the charges. So we need to determine the oxidation number. Bear that in mind. Always redox like that, huh? Because others don't take into consideration. Okay, very good. So balance now the charges. Okay, again, charges na ta. Okay, 8. Okay, there's a charges of positive. So that is 8. 8 times 1. Because plus is understood to be 1. So 8. Okay, connection in fairness. So 1. And then now for the permanganate, -1 times coefficient for the compound is 1. So 1 times -1, -1. Ganon. Okay. And then for the product, okay, manganese, Mn2 plus lang. Okay, that is, I emphasize because sometimes there are number of moles on the side. Okay, that's why I emphasize 2 times 1. Nagkataon lang siya. In this case, there's no number of moles beside the manganese. So what if there are number of moles in the future? You still do something like this, it's no longer applicable. That's why I said, okay, 2 times 1. Okay, okay, like that. And for the water, plus charges of water compound, you don't need to break the compound. Okay, it's always the charge of the entire compound during the balancing of the charge. That's also another identification. When you balance the charges, only single, it's not an issue. Maybe it will also break. So it will also about zero because water has a 0 charge because this is already a compound. Okay, a polar compound. Okay, unless specified that there's a charge, then there's no charge at all. Okay, here, the 0. So 4 times 0 is equals to 0. I emphasize all that because the discussion I said I see or I saw in the web I see or I saw in the website, in the Wikipedia doesn't understand 0. It's good to it's put 1 by 1 to understand that 8 minus 1 is equals to 7, right? 7. Hindi makalibog po niya. 7 is equals to 2. So both are positive. Okay? Like this. Okay? So both are positive. So positive 7 charge here. So positive 7 charge also in the, not also, 2 in the product. So the deficient is the 2. Okay? Take a look. Okay. Take a look lang sa taha. Okay, well, we are waiting taha. Okay, well, we are waiting for the connection to this tape. Something like, oh my gosh. Duka na juku. Wow. Ako. Okay. So to make it sure, charot. Okay. Okay, wait for mga friends. Because I'm still waiting for the reconnection. Wait a while. Ganun talagang mahina talaga siya. The connection is unstable. Please wait for your still currently. So for the like this, 7 and 5, right? Okay. Okay. Now this equation is here, right? 5. So and the 7 is here. But we are talking here of the charge. When you talk about the charge, it means the electrons. Okay, as I discussed a while ago, over and over again, this redox is referring to an electrons. Now, electrons is negative. Okay, negative. You always add the electrons negative. Okay, in here to make it equal. Okay, now, since this 2 is deficient, actually you will add 5 to compensate with the 7, right? Because in the law of conservation of energy or in mass, it should be equal. But this is not an atom, this is a charge. So it will not be in the charges. Okay? Here 5, supposedly we will add 5 here to make it 7, right? But since electrons is negative, so we will add 7, the 5 here in the 7. So 7 plus negative 5. Okay, because negative 5 is the electron.